Welcome to Georgia Highlands College Math 97 and Math 99 instructional videos. In this video segment, we'll be answering the question, how do you divide rational expressions? Well, just like with regular fractions, you never divide rational expressions. So, you simply change the division to multiplication with the reciprocal of the divisor, just like with regular fractions. Then, you've turned it into multiplication, so you simply follow the steps for multiplying rational expressions, which is factor all the numerators and the denominators, multiply them together into a single fraction, numerator times numerator, denominator times denominator, divide out any common factors between the numerator and the denominator, and then simplify by just rewriting in either factored form or polynomial form, whichever your instructor prefers for you to write it in. All right, let's take a look at the theory behind this, and then we'll take a look at an example as well. All right, so I have the theoretical outline of how to divide polynomials here, or rational expressions, excuse me. So if you consider P, Q, R, and S all being polynomials, where Q is not equal to 0, R is not equal to 0, and S is not equal to 0, then you have the situation of P divided by Q divided by R divided by S. Well, once again, we don't divide fractions, and that's all rational expressions are big fractions with polynomials in the numerator and denominator. You multiply by the reciprocal of the divisor. So you can see here I changed division to multiplication, and we flipped or wrote the reciprocal of the divisor there. And then we just proceed through by multiplying the numerator by the numerator, the denominator by the denominator, to get our resulting rational expression. All right, so let's take a look at this example. When we start out with the example, x squared plus 5x plus 6 over x squared minus 25 divided by x plus 2 divided by x plus 5. So our first step in this process is to simply rewrite this as multiplication of the reciprocal for the divisor. So x squared plus 5x plus 6, that first rational expression stays the same. It is the divisor that you need to take the reciprocal of. We change to multiplication and flip that second rational expression, x plus 5 now over x plus 2. And if you'd like an explanation as to why that happens, please go back and watch our video on dividing fractions, and there is an explanation as to why you multiply by the reciprocal, how that's the same thing as dividing by a fraction. All right, so we have our new problem written here, turned it into multiplication. Now we just need to follow through the steps of multiplying rational expressions. So the first step is to factor all numerators and denominators if possible. And our first rational expression, we can factor both the numerator and the denominator. The second rational expression is factored. We have a factor of x plus 5 in the numerator and a factor of x plus 2 in the denominator. So how do I know that that whole x plus 5 is a factor? And that's because it's made up of terms. So since we have that plus sign between those two, that entire numerator is a factor right there. All right, so if you want to write parentheses around anything like that that you know is a factor, that's a good idea, just to help keep it straight in your mind. All right, let's start factoring that first rational expression. So we have x squared plus 5x plus 6. Our leading coefficient is 1, so we can use the method of finding the factors of positive 6 that add to make positive 5. And those factors are 3 and 2, both being positive. So this first trinomial factors as x plus 3 times x plus 2. Once again, if you're rusty on your factoring, we have videos on that as well that you can go back and watch. And we can also factor the numerator of that first rational expression, which is x squared minus 25. This is a difference of squares. Remember, we can verify that this is a difference of squares by saying what can we square, what can we multiply by itself to make x squared, and that's x. What can we multiply by itself to make 25? That's 5. So since we verified that this is a difference of squares, it factors as x plus 5 times x minus 5. All right, so once again, there's no factoring to be done in the second rational expression. So we just need to rewrite, inserting our factored forms here. So we have x plus 3 times x plus 2 divided by x plus 5 times x minus 5. And we are multiplying that with x plus 5 divided by x plus 2. The next step in the multiplication process is to multiply it all together in one big single fraction. So x plus 3 times x plus 2 times x plus 5 divided by x plus 5 times x minus 5 times x plus 2. Now we're ready to divide out common factors, remembering that anything divided by itself is 1. Anything divided by itself is 1, except for 0. You know, 0 always gives us weird situations. So, all right, we have all of our common factors divided out. So we simply simplify by rewriting what we have left over. X plus 3 divided by x minus 5 is what we end up with when we multiply those two, when we divide those two rational expressions. All right, so I hope that this has been helpful for you in understanding how to divide rational expressions. Once again, you never divide rational expressions, which is nice. That's why we have a smiley face on the end there. You simply change it to multiplication with the reciprocal of the divisor, and then follow through your steps with multiplying rational expressions. If you have any other questions about this process, please make sure to contact your Georgia Highlands instructor.